Has the deep-rooted question of whether or not our species is extraordinary in the universe at long last been addressed? We may be drawing nearer to a game-evolving finding thanks to the James Webb Space Telescope presenting K2-18b, a faraway exoplanet that has recently become a point of focus in the field of astrobiology. Its atmosphere included an oddity that James Webb tracked down, which may demonstrate the presence of life: the atoms that make up water vapor, methane, and the very rare compound dimethyl sulfide. These aren't totally at random. Maybe these are the biomarkers that have been astounding researchers for such a long time, suggesting that extraterrestrial life does indeed exist. Our new guardian of the solar system, James Webb, is equipped with the most cutting-edge space hardware ever manufactured. Its mission is to tap into the unknown and perhaps rethink our concept of existence in the complex universe of K2-18b. This is something you're ready to explore. We rely upon the telescopes of our technological wonders to refine our understanding of the universe as we travel farther into space in search of answers to puzzles that have perplexed people for a very long time. Among these, the James Webb Space Telescope stands out. We owe an incredible debt of gratitude to the Hubble Space Telescope for years of providing us with amazing and informative photos of the universe. Still, not even Hubble is without its limits. Presenting James Webb, a telescope whose mission is to expand our understanding of the universe through the power of light. The JWST's cooling screen technology is among its most astounding qualities. The size of a tennis court, this complex technical wonder blocks the heat of the sun, Earth, and Moon, making it far from a conventional sunshade. Just how crucial is this? As a result, the telescope can be cooled to very low temperatures, making it more sensitive to weak infrared signals emitted by distant stars. Exoplanets like K2-18b must be studied using infrared observations. Space dust can block or scatter visible light. However, infrared waves can pass right through it, allowing for much better and more detailed images. Infrared observations made possible by JWST represent a unique advantage in how we might interpret distant planets and not simply an achievement. What new information could we hope to uncover as our attention shifts to K2-18b, the 124 light-year distant rock? K2-18b resides in the constellation Leo. Yet, it's more than that. The habitable zone around a star is known as the Goldilocks zone, characterized by temperatures that are perfect for liquid water to exist. K2-18b follows this same orbit around its parent star, K2-18. However, how could it be different from other exoplanets that occupy similar orbits? Scientifically speaking, K2-18b is a Hycean world, not your normal rocky planet. The discovery of habitable worlds with a marine surface and an atmosphere rich in hydrogen marks a new chapter in the mission for alien life. These planets provide conditions that could be akin to those around Earth's aqueous vents, which are known to be home to a wide variety of ecosystems. New data regarding K2-18b's atmosphere has been revealed by the James Webb Space Telescope's recent studies. The atmosphere of this distant planet contains various gases and components that potentially support life, or possibly life as we know it. These include water vapor, methane, and potentially, indeed, even dimethyl sulfide. The scientific community is delighted about the discovery of these atmospheric components. The academic community is abuzz with anticipation and speculation as they contemplate these findings and what they could mean for astrobiology and the search for extraterrestrial life. The curious atmospheric composition of this Hycean world raises the fascinating possibility that it holds the key to understanding life beyond Earth. What does the future of astrobiology hold in light of its extraordinary circumstances? One of the most challenging and potentially rewarding aspects of exploring extraterrestrial planets is learning about their atmospheres. The strange environmental, the structure and particular livable zone position of K2-18b make it a convincing contextual investigation of how invigorating and productive these sorts of examinations might be. A totally different cocktail is presented by K2-18b contrasted with Earth's climate, which comprises of trace gases nitrogen and oxygen. The hydrogen-rich atmosphere of this exoplanet is rich with scientific secrets, as it contains trace amounts of water vapor, methane, and even dimethyl sulfide. Investigating an alien planet's environment from more than 100 light-years away is difficult. Spectroscopy, a technique that concentrates on the transmission of light from a planet's parent star through its atmosphere, is utilized in this process. The composition of the air can be concluded by breaking down the unique fingerprint made when different molecules absorb light at various frequencies. James Webb Space Telescope's JWST infrared capabilities were significant in these discoveries. Numerous chemicals that were previously difficult to identify are now accessible thanks to the mid-infrared instrument spectrograph's extended frequency range. Researchers are considering what types of life could live in K2-18b's atmosphere here, due to the abundance of methane and the absence of ammonia. Since biological processes on Earth frequently result in methane, the discovery of this gas on K2-18b raises the interesting possibility of previously unnoticed living organisms adapted to a hydrogen-rich environment. Moreover, a subsurface ocean might be present in view of the atmospheric composition of K2-18b. This raises fascinating questions about the dynamics of the atmosphere, sea interactions, and their potential impact on the livability of the planet overall. Are we going to learn anything new about habitability and extraterrestrial life from its atmosphere? Average Earth-like settings strike a chord when we consider the probability of life. Regardless, we have found proof of life on Earth in previously impossible areas. Investigating extremophiles or organisms that thrive in harsh circumstances could shed light on potential extraterrestrial life. Aqueous vents found deep within the Earth's oceans eject heated water that is plentiful in minerals, forming an ecosystem that is both dark and overflowing with life. There, thermophiles and acidophiles prosper, causing serious qualms about our long-held suspicions regarding the conditions vital for life. Do you think exoplanets like K2-18b may be home to life like this? Novel conditions for previously unseen living organisms exist in K2-18b's hydrogen-rich environment. Methanogens are a kind of microorganism that flourishes in oxygen-exhausted settings and produces methane. On Earth, we may look at a planet where extremophiles that love hydrogen prosper. If the methane in K2-18b's atmosphere is biologically produced from the acidic riot into streams in Spain to the Siberian tundras, the investigation of extremophiles widens our understanding of the conditions that can support life. The fact that life might be found on Earth in such a wide range of harsh circumstances makes us reconsider the biological limits of life beyond Earth. As a potential exoplanet with a hydrogen-rich atmosphere and a sea beneath its surface, K2-18b is a prime contender for extreme life. Examination, perhaps this distant planet is home to an alternate sort of outrageous life, one that has advanced to flourish in its own particular climate. What could the developmental history of outrageous life on K2-18b be like? Complex life on Earth evolved from simpler structures that lived as single cells. Is it conceivable that under optimal conditions a similar cycle may happen on different planets? Dimethyl sulfide, DMS, could be available in K2-18b's environment, which is one of the most interesting things about concentrating on it. This compound, which could be a potential biosignature, is routinely made by phytoplankton on Earth. Does its presence on K2-18b and other exoplanets suggest the chance of life? In the wake of being oxidized in the atmosphere, DMS contributes to cloud development in the world seas. The revelation of life beyond Earth might pivot on its presence in an exoplanet's atmosphere like K2-18b. We are still in the process of testing K2-18b for the possible identification of DMS, albeit such convoluted mixtures can be distinguished by the JWST's mid-infrared instrument. Their presence should be confirmed by careful examination and expert assessment. Researchers are euphoric about the potential biosignatures found on K2-18b, like DMS. In any case, it has also ignited a contention, as is common with any revolutionary finding. What DMS implies for K2-18b is a contentious subject among scientists. Some see it as a promising biosignature candidate, while others point out that molecules with similar structures can be produced by abiotic processes as well. The difficulty and complexity of interpreting extraterrestrial data is highlighted by this conversation. Suspicion has often welcomed cosmic discoveries throughout history. At first, many people didn't believe Galileo when he said that Jupiter had satellites. There was also a version when the first exoplanet was discovered in 1995. The significance of skepticism in the scientific process is featured by these historical models. No single chemical or observation is critical to the search for extraterrestrial life. Scientists are keeping watch for biosignatures that, when combined, could provide strong evidence of life. Is it conceivable that DMS, along with other biosignatures such as methane and water vapor, forms a larger picture? Until further data is accumulated, the discussion is likely to continue. The verification that DMS is a real biosignature might be approaching from future missions with even more sensitive instruments, provided that technology continues to progress. Does DMS hold the key to finding extraterrestrial life, or is it simply a distraction? In any case, matter your position, the ongoing conversation highlights how science is dynamic. Our understanding of K2-18b and other exoplanets has been significantly improved by the James Webb Space Telescope, but this is just the beginning of space exploration, a long and winding road. How might technology develop in the future, and what lies beyond this huge attempt to expand how we understand the universe? Another revolutionary project is the Extremely Large Telescope, ELT, expected to be completed by 2025. The world's largest near-infrared optical telescope, with a primary mirror diameter of 128 feet, will be revealed. Biosignatures found by the James Webb Space Telescope might be confirmed or disproven by its unrivaled sensitivity. Discoveries from the James Webb could be enhanced by information from another upcoming mission, the Large Ultraviolet Optical Infrared Surveyor, LUVOIR, which, with its flexible operating frequencies, can obtain direct images of exoplanets and accomplish more in-depth atmospheric evaluations. Impetus technology advancements are crucial as we aim for exoplanets farther away. Molecular impetus and other potential methodologies, including antimatter drive, could allow probes to explore exoplanets within a human lifetime by significantly reducing journey times. We have a prior video that discusses the potential and challenges of interstellar travel. We should pause to contemplate the philosophical repercussions of our quest for extraterrestrial life as we stand on the cusp of potentially game-changing discoveries. How does this journey influence our perception of the universe, and what sorts of worries does it raise about what lies ahead? A new mystery is the capability of red dwarf stars throughout the cosmos, which are often disregarded. They are fascinating hosts for planets that could support life due to their stability and longevity. We would be affirming the presence of life beyond Earth and suggesting that the fundamental blocks of life are more universal than we previously expected if we found extraterrestrial microorganisms or other forms of life on planets like K2-18b. In our quest for vast knowledge, what secrets will the approaching decade uncover? Would we encounter more complex mysteries that challenge our understanding, or would we demonstrate the presence of extraterrestrial life?